Hello everybody, today we're going to talk about mechanical watch movements. We're going to talk about calibration of mechanical watch movements and how it really actually works. In brief, the mechanical watch movements or automatic movements were invented around the 17th and 18th century, really a long time ago, and they exist until now. Many of the parts were modified and a bit changed in order to achieve better accuracy. So today these watches really achieve impressive accuracy comparing to the time they were actually invented. I want to show you a certain kind of watch. This Psycho 5 is a very classical watch, which is not it's not being manufactured anymore. It's quite an old watch. It has a movement that is called 7S. That's the type of the movement inside of it. And also that 7S movement is discontinued. It's not manufactured anymore. I'm going to show you how to calibrate the watch in this video. As a first step, we're going to actually remove the case of the watch with this dedicated tool. You can see the tool has two pins, and the tool can be shifted by hand to the right place, in order to attach the watch in the right spots and the exact place where you can open the case. Now I'm trying to adjust it to the exact case. Now I am actually opening a gap, and then I try to put the pins inside the holes of the watch, and then I close that wheel in order to leave it in the place where actually I adjusted it to. Now I'm moving the case. I'm trying to rotate the case. You see the direction of the rotation as I do it. Once it becomes very easy, I'm rotating the rest of the rotates by hand. And now you can see I lifted the case, and you can see actually the heart of the watch, the mechanism of the watch. Now the mechanism consists of many moving parts and wheels, and two of the main important parts that I want to talk about is this weight, or the oscillating weight. You can see it oscillates, it moves. And the other very important part is the balance wheel, which is here. I'll show it with the tool. This is the balance wheel. This is the oscillating weight. The balance wheel has two levers, a big one and a bit thinner one. The big one should be left untouched due to the complexity of calibrating it, and I think that at this video I won't really focus on the big one, even though I can. The small one, or the thin one, is the one we actually want to focus about. The thinner one is the one that should be moved in relation to the thicker one. Now the movement has the direction of the movement is everything you have to know. As you can see on the watch, you can see it's written, there's a plus and a minus. A plus means that you accelerate actually the spring of the balance wheel, and you receive a faster watch movement. The minus one is actually deaccelerating, bringing the watch to a slower pace. Now what you can see the lever. I can explain it without looking at the plus and the minus in a way that it would put more sense to it. Once you once you move the thinner lever towards the bigger one or the thicker one, you actually lose the spring. You lose the spring because they get closer to each other, and then the spring is longer, and it receives a lower pace. Once you enlarge the distance between them, the two pins or the two levers, the spring is stretched, and once it's being stretched, it gains more speed, and it puts the watch in a higher and larger pace. Now we're going to see how I do it in real life. I'll try to get the camera closer. Now, as you see the watch movement, I pick the tool. I use I use this side of the tool, not the one with the pin, but the other one. which has 2 pins attached and quite a hole between them. Now what I do, I just grab the thin lever and I distance it a bit by using a bit of a force, but very, very mild force, very gently. I just push it far from the thicker lever. When I push it far from the thick lever, I actually tense the spring and make it run faster. If I do it to the opposite direction, the same action to the opposite direction, then I push it closer to the thick lever. Once I push it a bit closer, I actually loose the spring, and the watch becomes slower. It runs in a slower pace. You can see that here again. I'll try to, here it's focused now. You can see both the levers and the wheel behind them moving. Now, an important thing to know is that if you touch the balance wheel or the spring behind the balance wheel, the movement would be severely damaged and it wouldn't work. It would cease to work, and actually it would be damaged completely. So bear in mind that you must never touch the spring. You must never get closer to the spring. Therefore, I use this type of tool, because you touch the lever with this part of the tool where you actually grasp the lever, and there is less probability of actually slipping over it, because it catches it with its 2 pins from both sides. Now that's how you do it. The way you start by is actually you calibrate the hour of the watch, comparing to watch sites over the internet. For instance, you pick a watch site that is quite good, and you calibrate the watch with the time that you see on the site, and then you give it a couple of hours or a bit more, and you see how the watch is progressing comparing to that site. For instance, if you see that the watch is slow, you understand that you have to actually distance the thin lever and make it run faster. Everything that you do should be very slow and very gentle, and every movement of the lever should be a very small movement. You have to do it patiently in very small portions, because every big portion with this micro movement would make a lot of difference, a huge difference. Now again, I would address that micro mechanism, and I would say that it's very delicate, and you must touch it and work on it with in a very delicate manner. Don't ever apply a force towards these parts. Always try to move things slowly. If something doesn't move in a slow manner, it means it wouldn't move if you apply more force to it. So if something doesn't move in a slow manner, you have to check if you're doing the right thing, or if there's something stuck or something that doesn't move. Maybe an amount of oil should be applied, and that's how it goes. I will also, in my next video, I will speak about calibration, more scientific calibration in terms of hertz, which is the amount of movements per second in physics. And I will talk about the manufacturer's data sheet and how to actually achieve the tolerance that the data that are stated on the data sheet, with dealing with the amount of hertz and calibrating by hertz, and not only by hands, or not by just comparing it to another clock. That's it for now. I'll be happy if you subscribe to this video, and also put on the bell, and I will be happy to see you in other future videos that I'm going to post. Thank you very much, and I hope you enjoy that.